Welcome to the AAD Aside, a series of short video discussion based on the debates that are going on at the Anil Agarwal Dialogue 2020. And so we have here with us Professor A.P. Dimri from the Jawaharlal Nehru University in Delhi. And he just spoke about the Western disturbances and how they are important for the weather in the north and northeast of India, and how they are also a primary cause of a lot of extreme weather events that happen in this region. And also a lot of the people who live in these regions depend upon the rainfall and the precipitation that the Western disturbances bring in to the region. So we'll be speaking about his talk, what he gave at the Anil Agarwal Dialogue. So, sir.
Yeah, thank you very much for giving me a chance to speak on Anil Agarwal Dialogue. It is really, I appreciate that CSC is doing a lot of good work on environment and pollution. Coming to the topic of discussion of Western disturbances, in the recent decade, the issue of Western disturbances has become more important in the context of linkage towards water, its storage in the form of glacier, cryosphere, permafrost over the Himalayan region, because they mostly fed the precipitation in the form of snow, solid precipitation over the Indian Himalayan region, ultimately, which is giving life and feed to most of the North Indian rivers. So Western disturbances is primarily, which is the notion goes, they are disturbances originating in the west and traveling in the upper atmosphere in the subtropical westerly jet and arriving over Indian subcontinent in winter time. And most of their frequencies are in the month of December, January, February, roughly 4 to 5 per month on an average. And in the course of their travel, genesis, evolution, they pick up a lot of moisture, character from the Atlantic, Mediterranean Sea. The addition of Western disturbance when it comes over India is that it merges with the mid-tropospheric low, which is existing over the Indian western coast, and hence it gets more intensified when these two merges in the Western disturbances. By virtue of that, when it arrives over Indian subcontinent, it gets more moisture from the Arabian Sea also. So the moisture incursion is taken from Arabian Sea in addition to what it has picked up on its way arriving over the Indian subcontinent. Prior to that, if you look at the Indian Himalayas orography, the interaction of this WD with the Indian Himalayas have a very huge role in orographic control in forming the precipitation mechanism, and that is one of the important reasons that eastern Kashmir gets more precipitation than western Kashmir. If you look Leh Ladakh, they are cold desert. So the precipitation distribution in conjunction with WT have a lot of interactions which are very complex in nature, very non-linear in nature, and simultaneously being winter, it's very important to know when liquid water and solid precipitation occurs over the Himalayan region. Yeah.
So two of the events that I would like for you to cover and tell us more about are the dust storms that happened in 2018 and the cold waves that we have seen in the past two years. So both the December cold wave last year and the December cold wave this year, 2019 and 2018, both happened because there was a lack of strong Western disturbances in the month of December. And so what causes Western disturbances to not be strong sometimes? That it's not a trend, but sometimes it happens. So I'd like you to tell us a little more about that.
See, when we say Western disturbance is genesis, evolution, and its dissipation, there are various mechanisms working in whole life cycle of Western disturbance. In view of the specific question of cold wave when you are talking, we have to understand that moisture and temperature, they act together and they have a huge interplay to work on. When primarily you are telling cold wave, I know it's a standard definition of 5 days or something like that. I don't remember exact numbers. Temperature, mean temperature has to be less than that. So cold wave, when it's occurring, it means that we are mostly talking of the temperature factors rather than precipitation or moisture factors. In view of that, in these 2 years, absolutely you are right that cold wave were extended and there was a deficit amount of precipitation comparative to the normal of winter happened. So when there is less amount of moisture available in the free atmosphere, maybe in the form of precipitation or water vapor or liquid water, whatever it may be, your cold wave extended bit longer, and hence the last 2 years we have episodic cold waves comparatively longer happen, which is not the case this particular year, because this particular we have good amount of snowfall in higher reaches of the Himalayas. So moisture is kind of controlling the temperature and simultaneously temperature also. So there is a kind of feedback mechanism happens in moisture temperature feedback. You cannot dissociate them. So last 2 years were dry winters, and hence you have a cold wave impacts, whereas this year we don't have that much longer cold waves. Now I'm coming to the dust storm, which you have said most probably you are talking in the Rajasthan or western northwest India. Dust storm is primarily is of the form that how much temperature rise is available in the free atmosphere, and by virtue of these perturbations your dust is lifted from the surface and lifted up to the free atmosphere up to certain extent, and that dust storm can keep moving for certain. So it has more to do with the atmospheric energetics to sustain the dust in the free atmosphere, and hence if you have a warmer atmosphere, your atmosphere is going to be rarefied. And by virtue of rarefied atmosphere, the mass loading of the dust is getting lifted from the energetics available because of the warmer temperatures, and by virtue of that your dust particle which are lighter in nature are getting lifted by virtue of availability of this energetics. And that's why is the number of dust storm is seen more. And I think, I'm not sure, but there are studies which says that there are likelihood of more dust storm to form, particularly in pre-monsoon time, which is March, April, May.
So one of the reasons that these research papers also talk about is the extension of the western disturbances into the pre-monsoon season, where they usually were never there. One instance was the Uttarakhand floods, where the western disturbance was recorded in June, which is very rare. But even in the pre-monsoon months, usually the western disturbances are not as active, and now they have become active. So is there any reason for that?
Yeah, I agree with you. In recent years of this particular decade, mid-latitude interaction with the Indian summer monsoon were seen more pronounced. And as you said, 2013 episode of Uttarakhand flood, it has a huge interaction of a western disturbance which traveled in the month of June, which is very unusual otherwise. As I said, the average there in November to April. So June, this freak western disturbance when come in the north, it led the monsoon march northward very extensively, and this hypothesis was given in long back in 1959, I think, Pisarati and Molakar. So in our work we proved, and we call it pulsatory extension of monsoon. So it acted as pulse because in north there is a low pressure area, and hence monsoon trough quickly moved northward in the month of June itself and brought flood. Of course, there is a different mechanism. Similarly, this happened in the month of next years in flood in Jhelum, right? In another year, flood in Jhelum. So I think there are signatures that in recent decade WDs are freaking out in the month of monsoon, summer months also, which otherwise is not used case. It can be linked to the warming of the climate, most probably. Yeah, because some of the cases which you are talking has come so down southern latitude, which otherwise is not the normal case. So there are cases that WDs are coming to down south.
And now to wrap it up in a way, I would like you to tell us how can we forecast western disturbances better, where the research should go, and what are we looking at in the future?
That's possible. That's absolutely possible. One of our recent work is published where we tried hard to calculate the western disturbance index, right? So we understood what is western disturbance dynamics, thermodynamics, structure very well. Now based on this structure, we have calculated the WD index. Now we know the index. Based on this index, if we calculate the index in future models, basically we want to talk in the future. So now with certain uncertainty in the WD case, if the variability we understand well, and we calculate the western disturbance index, and we can definitely tell what is the index. Based on this index, we can say it's a easy WD, extensive, extreme. In fact, we can classify with certain threshold. So maybe we need to see now with this WD index, what is the climatological western disturbances, and generate certain classification of extreme, rare, like that, very rare kind of extreme. And then basically based on WD, it's easy to forecast based on the variability. But once you have a benchmark index, it's very easy to forecast for operational point of view.
And where is then IMD going wrong in its forecast of western disturbances? Because sometimes they are right, sometimes they get it way off. So can they build better models?
See, models have certain weaknesses because they cannot be perfect. They have a predictability limit. Knowing that, forecasts have to be seen from various angles. It's a synoptic, quantitative, qualitative, model-based, observational analysis. So certain limit of error always remains in forecast in any field. Forget about weather and like that. So error remains because of the western disturbance where variability is like that. The precipitation amount becomes very, very less in that forecasting notions, how to variability forecast. So in the perfection of model with the development of more models, there is definitely chances of better forecast in future.
Okay.
Time to come.
Okay, so we'll end it there. So this is to conclude our little session on western disturbances. Hope you have understood more about western disturbances and how they act and where the research is going in the future. Thank you.
Thank you very much.